Hello everyone, today we are going to talk about chapter 12.3 cosine ratio. And in last session we learned how to find the sine theta or sine ratio in the right angle triangle, right? We have already this formula for sine theta. It is the opposite sides divided by hypotenuse. Okay, and then for this chapter we are going to learn cosine. For example, this one cosine this theta, then the ratio is about the adjacent sides divided by hypotenuse. Okay, just memorize this formula, because in this chapter we are going to learn the phi ratio between these any two sides of this phi side, right? So this time we are going to learn the ratio between these two sides, adjacent side and hypotenuse. So how can we memorize this formula? I can tell you some ideas by myself. And first of all, to compare with the sine theta we learned last session, you can see both of them had the hypotenuse, right? And also the hypotenuse, the position of it is also in the denominator, right? So you can memorize in this way, that is, for sine theta or cosine theta, both of them involve the hypotenuse. That is the longest length in the right angle triangle, right? The longest length. Also, you can find the hypotenuse easier because it is just the opposite to the right angle, right? Opposite to this one. Also, it is the longest one. Then for sine theta, the numerator will be the opposite side, right? For cosine theta, the numerator just another side, that is the adjacent side. So how can we distinguish between sine theta and cosine theta? I may use this idea to memorize it. For cosine theta, you can see the adjacent side is here, and the theta here is in between this hypotenuse and this adjacent side, right? Just at the middle between these two sides. So you can see if I draw this arrow here, you can see a C here, right? A C. So this one cosine, okay? Just a trick. You may use this method to help you to memorize which one is cosine. Then for another side divided by hypotenuse, then should be sine, right? Okay. So you may memorize in this way. Then now I'm going to tell you to how to use the calculator to calculate the cosine theta, right? Because you know that usually we may make use of the calculators to calculate sine, cosine, or tangent in the next section. Okay, so I'm going to show you the calculator. So this one, calculator. Last time you know that the sine is here, right? Sine here. Okay, then cosine is just the next one. That is this one, cos. So just cosine. For example, I want to calculate cosine 30 degree, and then you can see the answer. Oh, very accurate, right? 0.866 something, right? For example, we want to calculate cosine 60 degree. Oh, this one is much beautiful. It is 0.5, right? Then you may use this one, cosine, and then put the degree inside. Okay. Then and talk about for example, for example, a right angle here, theta. This one x, this one y, this one z. So if you make use of what I have said before, how to memorize the sine and cosine, you can see cosine theta. It's first of all, we know that we must find the hypotenuse first. The hypotenuse in this time should be y, right? Because it is opposite to the right angle. Also, it is the longest side in this right angle triangle, right? So I put the hypotenuse on the denominator, because sine or cosine hypotenuse is always in the denominator. Okay, the longest one is in the right angle. Then for cosine, we know that this C, right, just the angle is in between the hypotenuse and adjacent side. So you can see theta here, the y here. So the adjacent side should be z. So the cosine theta in this triangle should be z divided by y. Okay, z divided by y. Then of course, if I want to find sine theta, then it should be the hypotenuse is still y. Then we have already find the z for cosine theta. Then sine theta should be x over y. Right? You may memorize in this way. Okay. Then I will do the exercise in the next video, but I'm going to talk about one more properties about cosine theta. First of all, from sine theta, last session you have learned that for sine theta, when the theta is increased, there is from for example 0 degree to 90 degree. Then you know that the 0 degree and 90 degree cannot happen, maybe 1 degree to 89 degree, because in triangle we have only 180 degree for angle sum of triangle, and one of the angle is already 90 degree, so we cannot have one more 90 degree. Okay. So when theta increase, we know that the sine theta will also increase, right? It is what you learned in last session. And we know that the sine theta, the range is from 0 to 1. That means the maximum is about 1, or we may say the upper limit is 1. Remember this term in your chapter 4, right? And this one is the lower limit of sine theta, or sine ratio over J. So in this session, I'm going to talk about how about the cosine theta. Okay. For cosine theta, again, for example, if I have a right triangle here, and I draw again. Sorry. I use another line. This one. Okay, and for example, cosine theta, we know that this one should be the length of this one divided by the hypotenuse, right? Cosine theta is x divided by y. If I move this y, for example, I move it in I move it in here, have the same y here. Okay, same y. You can see the new right triangle will be here, right? The theta will become less, right? This one greater, right? This one smaller. You can see the x here will be larger, right? The x will be increased. So you can see from the same y, for the same y, the x, when the theta is decreased, the x will be increased. That means when theta is decreased, then the x will be increased. And as the y has no change, so we know that x divided by y will be increased. That means cosine theta is increased. To conclude, that means when theta increases this time, cosine theta will decrease. We know that for last session, sine theta will increase, right? But this time, it will be changed. Cosine theta will be decreased. You may have a note by your calculator to verify it. That is so sure. For example, cosine 10 degree is 0.9x4, right? It's very large. For cosine 20 degree, it decreased a little, right? 0.939. For cosine 30 degree, okay, 0.866 is also decreased. For cosine 50 degree, okay, it's 0.642. You can see when theta is increased, cosine theta, the number will be decreased. Okay, it is opposite. Okay, or in mathematics we may say it is inversely proportional. And so for cosine theta, we also have this range, that is the cosine theta is also from 0 to 1. That is, the lower limit is 0. The upper limit is 1. You may ask why. Just like the sine theta, that is, for cosine theta, we know that it is the adjacent side divided by hypotenuse, right? The denominator is the hypotenuse. It is the longest side in this right angle triangle, right? You are always the longest. So think about it. For a fraction, if the denominator is greater, this one is smaller, then this fraction must be less than 1, right? Must be less than 1. For example, 2/3, 4/7, right? If the denominator is greater than the numerator, then for the fraction itself must be less than 1, right? Then why it is greater than 0, right? Because the length cannot be 0, right? The length cannot be 0, right? So we cannot have something negative, right? Because all the length here are positive, right? So just because of that case, so we have cosine theta is the range of it is between 0 and 1, between 0 and 1. So I will talk about how to do the exercise by make use of this cosine theta, this formula, and how to make use of our calculators to find the answer in the next video.